Welcome to the July edition. My name is Jakub Savrel. Presenting with me is
Tinos, third time here.
Yeah, welcome on the show. And we also have via a remote link Rodrigo Nogueira online. Hi, Rodrigo. How are you doing?
Hello. Good. How about you guys?
Thanks for joining us. So let's dive right in, digesting all the tremendous deluge of news that has again come upon us, so that you don't have to spend hours on Twitter. Is Twitter still alive? Threads these days or whatever. So we're trying to make sense of all this development. So let's dive right in. Ellen Institute of AI, known from Semantic Scholar and Ellen NLP Toolkit, not maybe in use so much anymore, but they have a new CEO. Oren Etzioni has stepped down a while ago, and now they found Ali Farhadi as the new CEO, who's a professor, interestingly, of computer vision at the University of Washington. So maybe that will signal a shift from NLP more to that side of things.
Or maybe they're just borrowing stuff from CV for NLP, who knows?
Or it's going to be multimodal all the way. I asked him for comments whether there are any new directions to be expected, but didn't react yet. And another interesting personnel change is Noam Brown. Do you know what he had been working on until now?
I think it was mostly agent stuff.
Yeah, like reinforcement learning for gameplay. He was one of the main authors of the Kikero model at Meta. And he's joined OpenAI yesterday. So I think the speculation is that reinforcement learning will become stronger and stronger in training these large language models, and probably also having some self-play in the mix. Any other Google engineers who created startups yesterday?
Yesterday, no, but Itai created one like a month ago or two.
The other sort of major news in AI this month is that Nvidia H100s have become reality. They're actually available. You can buy them, I think. I haven't found them in any online shops, like for retail prices. Do you know what it costs?
How much?
How much Nvidia H100 costs?
What is the amount now?
About the same as a small family car, like a Volkswagen Golf or a stripped down Tesla 3. I've read that it's about $35,000 per piece.
But it seems like a cheap choice to rent one for a few hours if you need it.
And at Lambda, they're available for about $2 per hour. So that's, yeah, it's pretty affordable. I think it's about the same rental price as renting a car, actually, per day, about $50 per day.
And we've already seen some open source models being trained on them. And of course, maybe we're just going to keep seeing both private and public organizations training larger models with all these new clusters.
Absolutely. So a lot of news about people building huge clusters with these chips. Just to remind you, they're really a lot faster than A100s, and especially optimized for transformer models, right?
Which makes sense.
Which makes sense, yeah. And yesterday there was this graph here that was doing the rounds, and people thought, well, maybe that's actually a leak about the true nature of GPT-4, right?
Yeah, I was fooled for a second, but people did the digging, and apparently it's not accidental. It's just a different model from Google that exists.
So
it's a switch transformer.
It's a switch transformer. But it is a lot faster for that as well. So talking about revenue for Nvidia, I was actually a bit surprised by this because I think the embargo for Nvidia selling high-end graphic cards to China was a while ago, and now they already spent $1 billion to buy what?
I mean, it says that maybe they haven't fully kicked in, so buy as many as you can before you cannot.
Yeah. So I think the trick here is that Nvidia actually released not only the H100 but also the H800, which is kind of artificially speed limited and just flies under the current sanctions regime. Maybe it's like one of those electric bikes where at home you tweak it in the app and then it's back to normal.
So the sanction is based on a threshold on throughput or something.
On memory bandwidth. So ByteDance, well known of TikTok, of course, spends about $1 billion. So if I do the math quickly, that gives you about 20,000 of these cards. Not that much actually, but you can do a lot of training of large models on that. I think the situation until now was kind of that there was this chokehold by Nvidia, mainly through CUDA and the whole software ecosystem. It was very hard for competitors to break into that, but it seems there's light on the horizon. So the now just announced AMD chips, they actually have some pretty amazing specs. So the announced Mi 300X chip supposedly has about double the amount of transistors of the H100 and an amazing memory bandwidth that won't make it to China probably, and a total of 192 gigabytes of RAM. It's a pretty neat architecture because it's not actually one big die, but it's a bunch of chiplets, a little bit like the Apple chips that are kind of soldered together in one package. It looks like this could be a real competitor, especially because in PyTorch 2, people have really worked hard on the support for the native AMD instruction sets, and apparently you can just do everything that you can do with CUDA in PyTorch, and you can even exchange the device that you use to do the calculation during a training run. So this graph here apparently shows that it shows just as well. So real competition on the horizon. So in other business news, there's a continuing onslaught of huge investments going into the AI space. I think the one that, both in new investments and acquisitions. So actually Mosaic ML sold the business for 1.3 billion to Databricks, kind of focusing on the private deployment of very large language models in companies. And a similar amount, or the same amount, was announced by Inflection AI. Have you heard about Inflection AI?
They're the ones developing the personal assistant.
Right, the Pi model.
Yeah. Which
they've now also released as an API, right?
Which, well, now the investment is led by Nvidia, and what does that mean? That money is going right back into Nvidia.
Exactly. So what I thought was interesting is that Microsoft is actually also investing there, and they already have a pretty big bet going with OpenAI. So apparently they're kind of spreading their risks.
Sounds like a smart move.
Well, so some people apparently really believe that Inflection is going to make a dent. I think they announced that about 800 million of this staggering amount would go back immediately into building a supercluster using NVIDIA chips, of course. In other acquisitions, there was Thomson Reuters, which acquired Case Text, a legal tech firm, and various kind of startups, scale-ups received pretty lofty valuations, with Runway, the video generation company, getting 141 million investment, and Typeface about 100 million. There was also kind of another interesting round of financing for startups which don't even have, hardly exist yet. There's like the classical Google founder sitting on the porch and getting the blank check from Andrew from Sun, the guy. But so there's Yitai, as you mentioned, Rodrigo. Do you know more backstory about that one?
I haven't heard anything, only via Twitter. Yeah.
So yeah, I think they're got a little bit too excited about Flanty 5 and too frustrated about Google bringing it to market quick enough. So they got somebody to invest 58 million, and off they go with their own LLM.
And actually, I checked their website. They already have a ChatGPT like platform running already.
Probably it involves Flanty 5, I would think.
not be surprised.
Yeah.
But they have the know-how.
It has a very good licensing model to spit it out. And Dawakila and others from Meta mostly, right? It was at Meta or Hugging Face, not sure.
Invistro, I think it was Meta.
No, Dawakila from Contextual.
Oh,
yeah. He also started his own company to focus on application in companies for automating work. I can sympathize with that. That's Zeta Alpha. And in France, Mistral AI is also just 3 guys, and they topped the news and the list with 113 million kind of angel investment just to get started. I think most of this money is going to go back into either AWS or Google Cloud or Nvidia. So it's a good set of investments. What else do we have here? Oh yeah, OpenAI opened an office in London, supposedly to steal away some talent from DeepMind. And I think the last chart here is that the tech layoffs are really kind of winding down from the conference front. So we were at Berlin Buzzwords a couple of weeks ago.
What was it?
It was a wonderful conference. You can see all the talks on YouTube now. So you will miss the Berlin beer garden entourage and the nice weather there. And we have also interviewed quite a number of people. So large language models were all the rage, obviously. Many of the talks were about retrieval augmented generation, kind of how you can plug in your own data into large language models. And we interviewed a number of the sort of leading speakers from the conference on that. It's on our YouTube channel under Neural Search Talks. And this was around the same time, 2 weeks ago, CVPR in Vancouver. You were supposed to go there, right?
Well, we had a paper at the workshop, but one of the other authors presented.
Yeah. So another 3,000 papers almost published in CVPR. Here you can see a map from Zeta Alpha that we have made. So a lot of stuff about 3D computer vision, neural radiance fields, obviously, and all the usual computer vision stuff. Yeah, what else is new? Well, obviously we keep track of that using our own platform. With Zeta Alpha, you can discover all the latest AI research papers and GitHub repos and conferences and blogs and code. You can organize it for yourself in projects and then get good recommendations. And that's mostly how we spot the papers that we're going to highlight now. Connected to the search engine is this retrieval augmented question answering, which we have been working on for a while, which is a great way to actually be able to ask large language models questions and get factual answers, but also to connect it to your own private or proprietary material in your existing IT systems. So let's dive into the papers. This is the landscape of everything that's come out in the last 30 days or so. Usually we use a lot of Twitter signal to filter out the the hot and buzzing topics. That has been a little bit more difficult these days because Twitter basically completely stopped functioning in terms of any sort of APIs. We tried to pay, but
Even for pay customers, right?
they didn't help either. With a little bit more manual work than normal, we managed to pick out 10 gems that we think you should pay attention to this month.
A little bit more than 10 as a bonus.
Yeah, we always cheat a little bit because we start with 10 and then we add a few more. And of course, we have a little bit of fondness for the information retrieval space, so we always sneak in a few more IR papers. So let's get started with that. Did you read this one?
Yeah.
RoboCat. It's a very nice paper from the robotics domain. So what basically these authors, it's a very big group, people from DeepMind. They have built this kind of universal robotics agent. Well, universal, it controls robotic arms, not walking robots or drones. And they basically have trained a single model, which is super easy to adapt to different robotic arms. So it's based on the Gato model. So it's basically a big transformer that tokenizes all the different input modalities into one big stream of tokens, including the sensor information from the robot, the visual, and I think Gato also did video,
yeah, it was
games,
all types
and,
of inputs,
language, and all that. That's not here, but basically the this very large transformer model trained on this mix of token sequences is augmented with kind of visual goal seeking. So you can show it a picture and it will try to kind of find the way to that picture. And first it needs a demo. So it will take like a human remote control and see how the sensor tokens relate to reaching that goal. And then you can just show it another picture after a little bit of fine tuning, and it will automatically output the actuator tokens that lead it there. And it can do that for a new robot arm with very few examples. So basically, few-shot learning, you could say, or fine-tuning on a very small data set. Once it is fine-tuned a little bit and it can actually control this new arm, the agent itself will start to generate synthetic training data and then continue the fine-tuning on that synthetic data. So that was pretty cool.
Did you hear about I assume that it's not open source from DeepMind, unfortunately. But...
No, DeepMind is not OpenAI.
But did you see how good the application was?
Like a benchmarking in terms of how no, did you
No, not
look
really.
into that? No, I did see that they claim that this is the first foundational model that can control sort of any new robot, but that's particularly type of DeepMind-ish claim as well. In fact, there was this work, GNM, General Navigational Model to Drive Any Robot, which was from, I don't know, a couple of months ago from Sergey Levine's group, and they didn't cite that. And there was also this model, which it just came out last week, VINT, also from the same group at Berkeley, which also develops a foundational model for this kind of visual goal-seeking behavior with any type of robot.
I think this is all quite leading to that embodiment type of AI where it can actually control the environment around and interact.
Yeah, I think Gato really led the way there to combine all these different modalities, just throw it into one big transformer and let it run. So talking about multimodal models, This is actually from one of those very fresh startups, Contextual, maybe their first paper, and it already made quite a splash. So they developed this simple but quite powerful method to combine computer vision models with large language models to kind of give eyes to a large language model. And it's really, yeah, it's really very simple. So there were before all of these models which use all kinds of encoders and then have latent representations of the image and then try to align the internal representations of the multimodal model with those pre-trained image models. There are various ways. For example, Flamingo did this in a particular way with the latents from the computer vision, and Blip2, I think, was from Salesforce, did this in a slightly different way. And now William Berrios and his team from Contextual, they do it in a very simple way. They just take existing computer vision models that output language, like image captioning models or models that just describe attributes of the image. They throw together a whole bunch of them, 3 different ones, I think, and then just put all the textual output inside the prompt. And you would think that does not work.
But I guess the results show the opposite.
But they beat both Blip and Flamingo. So yeah, simple sometimes does it. And the code and the demo is online, so try it out. Another multimodal model is a small update to the Cosmos 1 model, which came out a couple months ago, I think in February. So Cosmos 1 was kind of a visual question answering model. You have an image and you can ask questions about it, pretty much like Flamingo. And the enhancement here with Cosmos 2 is what they call grounding. And basically what they mean by grounding is that they segment the language that's input to the model and basically connect the noun phrases in the text to particular bounding boxes in the image. And that means that you can not only show where those parts are, like in an explanation kind of way, but you can also use it during question answering. You can ask, like, what is this here? Or here in this example, what is this thing next to the boat? Or why is this animal? And you point at the tortoise and you ask, why is this one unusual? And it will actually say, well, it's a turtle, so normally turtles are slow, but this one is fast. Or you can ask questions about two different, the difference between two objects. So what I'm curious about is whether this would actually beat this lens model, and whether you could get the same just using natural language as a representational layer.
Well, you don't know until you try it. So
exactly.
And sometimes you see the opposite of what you expect. My bet would be with this one, honestly.
Yeah, I think it's pretty nice representational layer to have these bounding boxes. And again, it's open source, so you can try it out on the Microsoft pages. The next paper that we want to highlight is the DreamDiffusion. It's a Chinese paper where basically, so it's in this space of decoding what you're thinking by looking at the signals on some electrodes on your scalp. And before, this was done with fMRI, and now the possibilities are really expanding to do it with EEG, which just requires a simple cap with electrodes on your head. And they basically are able to take an EEG scan of your brain activity, and then regenerate the image that you saw.
Yeah.
Or
usually these type of papers get the attention of many non-AI people and kind of make them think that we are way far ahead from where we are. But with measured expectations, I think we can see the value of such papers, such proposals.
Yeah, that does kind of fire up the imagination of reading your thoughts, right? And if you look at the paper, it kind of discusses potential impact in kind of the artistic and creative realm. Yeah, you also get to think. I'm not sure I want to think. Want to know. Want the government to know exactly what I'm thinking all the time, especially in some countries. But hey, so what they do is basically train a really robust latent representation of EEG signals, and then they do use that as kind of prompt in the stable diffusion model, and uses fairly few examples that actually are paired. Right, so moving from multimodal and decoding your thoughts to computer vision.
Yeah, and I think we've seen quite how big the impact of the segment anything model from Meta, which came out a few months ago, but already every week almost you see papers on arXiv where they're taking it and tweaking it in some sense. This one is pretty simple, but actually quite efficient. What they claim is that since the segment anything model is based on a transformer architecture, it's actually quite slow in terms of processing the input and deploying it in real-time scenarios, such as robotic movement, autonomous vehicles, stuff like that.
Yeah.
So what they thought is maybe let's switch this.
It takes about a second or something.
I think
like
1
that, right?
or 2 seconds is what they benchmarked it on. And they said, okay, maybe let's find some more efficient architecture that is optimized on our hardware. So what they proposed is to just take that transformer away that did all the segmentation and identification of the objects, and simply have a CNN detector, which first detects every object in the image and creates a mask of it based on the YOLO V8 architecture. And then based on these masks that you produce, you want to kind of select one of them similar to what the segment anything model did. And you can either do this by selecting a point in the image, and then you'd have a very simple approach where you find which mask belongs to that point, or vice versa, or even select the region and say, give me the object that is in this region. So you kind of have an overlap with what the user selected and which mask is predominantly there. But I think the most interesting part here is the prompt guided one, where you type anything, any type of text where you want to identify in the picture, and then kind of cheating here, you're using clip, and you basically give the text embedding to clip, you get a representation, and then you get every patch from the image and try to find which patch basically describes what you saw. And this is very efficient because now you only need to do it on a patch level, and you automatically get the mask that you had from the previous step. And they're claiming this gives you a 50 times speed up. It does work pretty well. I've seen, like, if you go through their experiments, their results, the authors themselves say that where their method kind of breaks down is when you have very small elements in the image, and maybe the reason is maybe the CNN is not as effective at capturing and identifying the features that small. But nonetheless, it's quite a good model, and of course it's open source, so people can use it or even demo it on their website.
Yeah, it's got 4,500 stars on GitHub in like a couple of weeks, so attracting a lot of attention. And we have one more riff on segment anything.
Yeah, I guess this goes even further to show that this foundation model is quite strong. And this is actually.
But this is the original segment anything.
Yeah, it's the same
model.
Yeah, but it's just now they're taking it to video. This is similar to a paper we covered at the last edition, if you remember, where they're doing this point tracking across frames to kind of keep track of an element. And here they are combining it with the segmentation mask. So the user can select which points they want from an image to track and which points they want to not track, just to help the models better discriminate between what they are interested in and maybe adjacent information in the image. And then if you track the points with classical approaches of point tracking across frames, you can actually match where the mask moves across frames. And you get pretty interesting results, because then you can just say, okay, after an amount of frames, where did this point move? Oh, this is the same object before and after. And the authors have pretty interesting demos. I think we can show them and see how it does, basically what you want, right? You select a few points. It can be one object, two objects, however many objects. What you do not want to track, and then across time, you can keep track of the object that you're interested in. So this is obviously, again, many applications in autonomous driving or object detection over
master rayons. So now we're going to track, and then we're going to read the thoughts. But that's the next level. All right. So this was also an interesting paper. It was kind of the the counter example to the scaling laws, right?
Exactly. And
first we said you just need more parameters, and we said, well, maybe not more parameters, maybe more compute, like more total number of token exposures. But this was a bit the demasking of that.
Mm-hmm. And I quite like this paper. I think that would be my highlight for this collection. Basically, they're narrowing it down, first of all, to a code generation model, simply because that's very easy to evaluate.
Yeah, so these textbooks are computer science textbooks, right?
Yes, actually, this code from Stack Overflow and all these open collections of permissive licensed repositories. So what they're doing is they're saying, okay, there's a lot of code examples on the internet, but we do not want all of it. It's kind of similar to how you want to select good examples to teach a language model reasoning. In the same kind of sense, you want good code examples to teach a code generation model to provide helpful completions. So they collect some textbook quality data from the internet, and then they filter it down to about 6 billion tokens. And then they use ChatGPT.
Fully automatically, or
Yeah, they use some heuristic function to do it automatically. So they just have some annotation. They bootstrap it again with GPT-4, where it does kind of an annotation of this is a helpful example, this is not helpful. Right. And then based on that small collection, they create a model.
So it's not only about like quality, but it's also to some extent kind of active learning approach in the sense of selecting representative examples. Mm-hmm. Right.
But other than that, they also use GPT 3.5 just for efficiency and ease of use to actually generate even more examples purely from the docstring or the function name.
Right.
And then this is their main pre-training, which is about 7 billion tokens, I think 8 epochs on that. And what they find is actually a very crucial component is to fine-tune on just 180 million tokens of exercise and solution examples. So the authors, again, generate these with ChatGPT, and they see that doing this, the model can then, first, it performs really well. So with 10 times fewer parameters than one of the state-of-the-art, excluding GPT-4, and 100 times less data, they can get about as good performance or even better in one benchmark.
On human eval.
On human eval.
Yeah.
But also they find that this fine-tuning step is crucial because it helps some what they call emergent abilities, where the model has never seen a library in its fine-tuning, but it has probably seen it in its pre-training. But simply by seeing how people use common libraries, it can extrapolate and locate that knowledge from pre-training to actually understand how to use the new libraries. Of course, there are limitations here. It's just they only trained this for Python, but I think it's quite a strong direction to follow.
And Rodrigo, you've also looked at this paper. What's your take on it? Small is beautiful, or?
Yeah, but I think it's a really nice paper. One thing I like, it's when we're doing these pre-trainings, we need all these GPUs clustered together. So because we have a lot of memory to keep the states of the optimizers. But now we are kind of shifting the cost towards this offline stage where we do this curation, but this can be done in parallel. You're using cheaper hardware. And then now you have this high quality data set. You just do a bit of pre-training on it. And it also reminds me another paper from Microsoft Orca that they use GPT-4 to generate explanations. And they generated actually a bunch of explanations about, I think, 3 to 10 billion tokens, more or less. And they also fine-tuned, they got pretty good results in comparison to fine-tune on another 100 billion tokens. So it seems there is a trend now of having better ways to select our pre-training data so we don't have to spend that much time using this expensive cluster.
Yeah, only 4 days on an 800 cluster, which for pre-training a model is not really that much.
Right, so that's that equates to a small trip around France in a small family car, but still, yeah. All right, so
we also have an example on the next slide where just to see how different the data is. So if you show it, in one case, if you just use any kind of GitHub data, you have a lot of this boilerplate where you just initialize variables, which is not really helpful when you're training a model that helps you write code. On the opposite hand, you have good high educational data is what they call, where you actually have an instruction or a docstring perform matrix multiplication or do this Euclidean distance, which helps the model understand, okay, this is the reason it's built for.
So the academic professors here in the room will probably argue that it matters even which textbooks you use, because you might learn the wrong things. But that's the next level of this. This is another paper that you picked. So
yeah, it's also getting
quite a nice diagram here.
It's also getting quite some traction on Twitter from people that are mainly against the autoregressive models. So as we know, the problem that they typically fall into is once you generate one token that's wrong or that doesn't fit with the distribution that you're after, then there's no way to go back. You just have to keep going, keep generating tokens and somehow make this a good answer, even though if it's fundamentally wrong. So
this is to persuade the people who are saying it's just predicting the next word.
Yeah. So you kind of want the model to be able to stop predicting the next word, go back and try again. And this is doing it in a fashion where you can actually generate a backspace token. If you say the sky is green, you can say no, it's blue.
Yep.
And then they're trying to train this model in a reinforcement learning fashion, formulating this problem as imitation learning.
Mm-hmm.
So in general, you'd have, if you go in the broad RL literature, imitation learning is when you know your agent has to follow a path. And then if you go very far away from the optimal path, you penalize that to kind of bring it closer to where you want to be. So what the authors did is they generated data from a general text corpus where they introduced this kind of misbehavior on purpose. So you'd have a corpus where it says the sky is green, backspace blue, and then the model needs to predict that you need to generate these tokens when a mistake happens. So this kind of shows that if you teach the model to do that, and instead of using MLE loss, you use this distribution penalty with a bunch of distributions actually, the model actually learns that it's okay to go back when needed to.
So you actually explicitly materialize these tokens while training? Yeah. So in that sense, it's not really reinforcement learning, right?
No, I think it's actually trained with a policy loss. That's
so you use the policy to generate these data while you're training. Okay.
And they test it on GPT-2. They have a small, medium, and large, and they show, of course, training the full model is better than training just the head, but also showing that this scales better than just the typical approach of next token prediction.
And then when you're doing inference, you continue.
No, at inference there is no extra cost.
It's only training.
Yeah, this is only for the training. There's no extra cost for inference, assuming that the model has learned that when needed, if it makes a mistake, it can go back, and then it's simply next token prediction.
Right. And so last month we discussed this model called Tree of Thoughts. Do you have an intuition of how it relates to that? Because that also tried to explore like multiple paths and then looked at the quality of the whole sequence.
Well, I feel like the Tree of Thoughts paper is basically code that you wrap around your generative model to kind of glue together the good answers. Here it's all in the model, so the model has to learn when it needs to abandon the thoughts and go back to some other answer.
Yeah.
But
so,
it's
think before you speak, and the other is speak, and then we will figure it out.
Yeah.
All right. Yeah, this paper
kind of resurfaced recently.
resurfaced, but it was more hype than substance, maybe, right? Well, it has some interesting
Well,
points.
the findings are definitely interesting.
So why did it resurface? Why would it?
Well, it's the rumor that we talked about before. George Hotz started the rumor that actually, I'm for sure convinced that GPT-4 is a mixture of experts, and then all the kind of surrounding people said, "Oh yes, I also have."
Right. So people said he leaked that it is not that it's
a mixture
of expert model. But how can he leak it? He doesn't
work there.
He doesn't work there, right? I think he leaked that he speculated or something like that. And then everybody started believing it, right? And there was like other people had the same.
Yeah, I've heard so.
Yeah.
And that's how the story is being built by itself. But in general, we've known that mixture of experts are models that can combine basically the knowledge of multiple versions of a model at an inference, an efficient way at doing inference.
Yeah.
So,
but it's always kind of been said like, yeah, they're not, yeah, they have a lot of parameters, but they're really not as powerful as equivalent dense models, right? I mean, I don't think it has been thoroughly studied, but there was always kind of
I guess that was
suspicion.
The lack of many alternatives doesn't help with evaluating different approaches to this, since I think only very few are popular, like the switch transformer. I guess also due to the complexity of deploying and training these models. But what this paper is proposing is first they basically they're claiming that 1 + 1 is greater than 2, because yes, you might have mixture of experts and you also have instruction tuning, but when you combine the two, you unlock some potential that each individual technique doesn't have.
Yeah, so maybe you can explain it a little bit what the graphs mean here.
Yeah, so what they showed first is if you simply fine-tune a mixture of experts model on a particular task, downstream task, then it's been shown actually that performance doesn't improve, and the opposite.
Over the same sized dense model, right?
So I think this is what the green and orange lines show. First, you have your normal mixture of experts model, and then if you fine-tune it on simply fine-tuning on question-answer pairs, for example, performance drops. While on the opposite hand, if you have a normal model like T5 and then you instruction tune it, like Flan T5, the green to blue transition shows that performance does increase, which is how we got the value that instruction tuning is actually a better format than simply just in the raw format that you have in it for your tasks. But then they saw that if you, instead of simply fine-tuning the model, the mixture of experts model, you instruction tune this. So kind of each expert can probably adapt better to this kind of new task rather than thinking that the whole model is supposed to do this. They showed that simply by using 1 or 2 experts at inference time, with, of course, the normal mixture of experts selection using softmax of which expert is the most relevant, then we can unlock the potential that was lost during normal fine-tuning. And they show that depending on the task, more experts are training on more experts is better, or training on more tasks helps, but overall, it shows that performance can be maintained when using mixture of experts models. Yeah,
so mixture of expert models in summary are more suitable to instruction tuning than same science.
Which is kind of intuitive, right?
Yeah, because they're smaller models.
Smaller models, you can specialize each one for a new task. It's not kind of compressing all that knowledge to one model.
Yeah, interesting. So we still don't know whether GPT-4 is a mixture of expert model, but this is an interesting paper. Another very large model from Google is PaLM, which is not a mixture of expert model, as far as I know. Now it's been taught to speak and listen. Basically, same approach again. Make a multimodal model out of a unimodal, language-only model by mixing the other modality S tokens. So they basically create audio tokens on the input and the output, and train it on transcriptions, and they initialize it with the weights of the existing PaLM model, and then the audio tokens are decoded using the existing AudioPaLM model, and it seems to work like a charm. So
Well, usually the devil's in the details. How you glue these models together might not be as straightforward as you think, but I'm sure they have all the people that need to know how to do it.
yeah, if they haven't started their own companies yet, and maybe some of these 30-something authors already have, who knows? But they get state-of-the-art results on speech-to-speech translation. So I think that is pretty impressive. And somewhere in the small print of the paper, you can find that it actually has zero-shot capabilities generalizing to languages that PaLM was trained on, but that the speech models were not trained on. So they can probably do that. I think Sundar Pichai mentioned something about the model speaking a language which it wasn't trained on. He might have been referring to this model. Right, so to be a little bit more outside of the realm of just language and vision, there's also a lot of work going into modeling molecules, proteins, and DNA. And DNA happens to have very long sequences. And with transformer context lengths, you kind of don't get there with type of quadratic attention. So in this very nice paper, they have built a foundational model for genomic sequence modeling that can handle context lengths up to 1 million tokens. And they've built this new architecture called Hyena, which is actually also kind of approximating attention as a series of convolutions of various time steps. So they kind of having multiple time resolutions at the same time over the sequence, and build a pretty large model out of that. And I think in this graph here, you can see that they kind of by just increasing the sequence length far beyond what the transformer is able to do, they continue training for lower perplexity on these sequences, and then they're able to use the representations from this model for all kinds of downstream tasks. So that's worth reading and checking out if you're in the biotech space.
And in general, I think we see again how from one kind of subfield of AI, you get transferred ideas to others. And this is probably all gonna, it helps with developing the field so fast.
So you think 1 million tokens is a lot? Well, these guys from Microsoft, they want to show you that no, 1 million is not a very large number. 1 billion, that's a large number. There's 1,000 billions. And they use the whole first half of the front page of the paper to show that in a logarithmic scale graph. I thought that was pretty hilarious. Supposedly this new kind of attention architecture, Longnet, can scale up to 1 billion tokens. I think I've not seen actual experiments with 1 billion tokens in this paper.
I think it was up to 4,000 or 30,000.
And it's in some sense a very similar idea, kind of simplifying the attention mechanism to operate at different time scales. And you can, kind of hierarchically expand it without a lot of additional complexity. So that's Longnet. Maybe promising, but not proven yet. But we do love the graph on the front page. I think it should get the award for the best
How to get attention?
Infographic of the year. Rodrigo, you looked a little bit more closely at this paper, right?
That's right, yeah. So the idea behind this paper is that we want to evaluate the output of a model, and sometimes there's a lot of sensitivity in how we phrase differently the inputs. So it generates completely different answers. So the idea is that we now perturb these inputs, fit into a language model that will make predictions, and then we see how sensitive are the outputs based on this perturbation. In this case, they simply use negation, and they can measure then how is the sensitivity to these negations. And one thing that I like about this paper, and it's also in general that people are also always finding that using models such as GPT-4, there is a high correlation with human preference. But like Dinos mentioned, the devil is in the details. Like you have to pay attention how you actually use GPT-4 to evaluate the output of a model. In fact, there's another release from, I think, a week ago. It's called MT Bench from people from the LMC's group. They found some problems with the GPT-4 evaluation. For example, if you put one of the candidates, they're doing pairwise evaluations, and with one of the candidates at the beginning of the prompt, the model GPT-4 tends to have this give high scores to this first candidate than to the second one. So there's a bunch of tricks that you need to apply in order to make this evaluation robust. But once you do it and you compare with human preference, you see that you find that a GPT-4 can actually replace some kind of these evaluations. So this is another paper that I think brings another trick, I would say, to the table. Like you should make the small perturbations to your input and see how reliable are the outputs.
Yeah, and I think what's measured here is not evaluated by some external authority like GPT-4, but simply compared in terms of how much it changes, right?
Yeah, they
so
use all
it can also be used in a kind of production situation where you don't have access to a very powerful model to evaluate every model output.
Yeah, for each task they propose, so they claiming that they can apply this self-supervised strategy to measure the parametric knowledge of the model or how toxic it is, if it handles context well, but also more kind of engineering stuff like how sensitive is it to word order, or if we make a typo or tokenization error. And they show like for each case, okay, we have a correlation with a benchmark or some proprietary model like for toxicity perplexities model. And they show that, yes, if we just permute this input or add a negation to the sentence and the model is very surprised, that actually correlates with how much knowledge it has to answer questions on an existing benchmark like Trivia QA. And I think this is a very nice way of presenting the capabilities of a model in a more intuitive way.
And also to monitor them in production, really, right? I think it has that capability or that potential.
And of course, you no longer have to rely on data sets which might have been leaked online in the pre-training of models, or having to create a new data set for a specific capability, which of course takes time and human effort.
Right. So I think this alludes to the challenge that with large language models, prototyping has become super cheap and testing has become nearly impossible. Yep. So there's a whole line of work evolving around that. We're drawing towards the end, so I want to dive into some of the information retrieval related papers. And we happen to have one of the authors of this paper here in the room. Andrew, do you want to join us in the panel for a bit? Sure. Pull up your chair. So, this paper is a personal favorite of mine because it alludes to the intuition that there's this sort of strong correspondence somehow between this new approach to information retrieval using generative models and dense retrieval. So maybe you can quickly explain the sort of the gist of the paper.
Yeah, so the general idea is if you think about dense retrieval, what we're doing is taking the dot product between a query vector and a document vector. If you think about a generative model, there's this prediction head. And so in the last layer, what this head is doing is taking a vector as input, doing some projections with it, and then taking the dot product between that query vector and a set of embeddings, which correspond essentially to documents, maybe also transformed in some way. So this is still just the dot product between query and document vectors. It's just that we created those vectors in very different ways. So in this paper, we try to think of generative retrieval as dense retrieval and take a dense retrieval approach essentially to populating that vocabulary matrix in the generative model so that our training looks very different. It looks like dense retrieval. And then at testing time or inference time, what we're doing is basically just running the generative retrieval model normally, except that it's essentially doing dense retrieval because we populated this layer with embeddings created in this way. So it's really blurring the lines between the two different families, as I see it.
Yeah. So if you have you have a query at retrieval time, how does it actually kind of transition from the generative model into the dense model?
At inference time?
Yeah.
Yeah. So you have a query as input, and then you have a set of transformer decoders that are taking this as input. And ultimately what you end up with is a single vector that you then want to compare against the documents that are known.
Which in the generative approach is basically like a document ID, but now it happens to be one of the vectors that you use to do kind of approximate nearest neighbor.
Yeah, exactly. It's kind of like rather than learning these document representations from teacher forcing or from some sequence to sequence task, we learn them similarly to you would in dense retrieval, but then retrofit the model to already contain them. So I see it as a more direct way to learn these document representations. And I think it's interesting that the expressivity of this approach and also dense retrieval seem to be the same. Like in both, you create vectors in different ways, but at the end of the day, you're just taking an inner product between these vectors created differently.
Do you want to add anything to it?
And I guess one of
point
the main motivations for this is to kind of generalize to new documents and update the index, which is a known limitation with DSI.
Yeah, with this approach, updating the index is now trivial because you just create the representation for that document by running it through the model, and then you just add it to that vocab layer. So it's very easy to do, and it's analogous to what happens in dense retrieval.
And did you have a look at in any way that, like, let's say the representation that you end up with for a new document is really similar to documents that are related?
Not in this paper. This is something we're thinking about, and we have work going a bit further. This is on atomic doc.id, so we're thinking about how this relates when you have longer document representations, right? But this is still a single vector, and there's also these semantic hierarchical representations that are a sequence of vectors.
Right. So there's still a lot of room for and I think sorry, we should have shown the diagram here, and you guys evaluated it and it does pretty well on MS Markov, right? Which has been kind of difficult for DSI and similar approaches.
Yeah, it seems hard to scale up with the sequence to sequence, like teacher forcing type of training. But here it's easy because we just create a document representation and add it. And you see it's really close to AMPs, and it's not that much different than AMPs, right?
Not a super strong baseline. Okay.
No. But we're not, so we're using a T5 small. So we're basically trying to show that this will work, not trying to maximize the metrics at all.
Yeah, very cool. Thanks. So generative retrieval is all the rage. Seems to be like a very fresh way of thinking about things because it's inspiring a lot of new papers. This was another one that we kind of picked out. You had a look at it.
Yeah, which again is not rediscovering the wheel, but using all these new components of generative retrieval and actually combining it with the long-studied literature of learning to rank. So what they do is they kind of follow a different approach to generative retrieval where you don't have IDs, but you kind of have substrings of the document or some related query, generated query about it, and you treat that as a document identifier. And then on top of that model, which is existing work from the same authors, I believe.
Yeah, which was introduced kind of in this Belleville-Aqua paper, right, last year.
And then they kind of advanced this by saying, okay, once you've trained a model that can generate these synthetic identifiers, then you can add on top of it some extra loss where you can actually perform learning to rank to optimize this passage ranking. Because generally for the generative retrieval models, you just have a query and you produce a document. It's not quite obvious how you create a list to produce a ranking list. So what they do here on top is you do have the loss that comes from the generative model that produces an identifier for a query, but also add extra terms that try to maximize this ranking list to have the higher scored documents on top and then push the more relevant ones to the bottom. And they do show that it has outperformed all previous approaches.
Not as good as your paper. MRR at 10 of 25. Okay, good job, but
Different approach.
yeah, it's a worthwhile new approach. All right, so thanks for joining us in the panel, Andrew. We're wrapping up. I guess you are also going to SIG-IR.
And I'm going to ACL.
You're going to ACL next week. So these are the two big upcoming conferences this month. There is a generative IR workshop at SIG-IR. I don't know if it's accessible through online only, but it's definitely worth checking out. And lots of new papers coming in from ACL. They're almost online, so we'll be indexing them and following them through in Zeta Alpha. Rodrigo, you're going to?
SIG-IR, yeah.
SIG-IR. Do you have a paper there?
I do, EXA-Ranker, yeah.
Oh, EXA-Ranker, yeah, that's a very nice paper as well. On explainable ranking using large language models. So that wraps up this month's Trends in AI. This was one last paper that we didn't want to miss. It was a little bit of a faux pas from the University of Wuhan, which named their latest model BAT-GPT, kind of a bit tone deaf, but it was notable paper title. That's it. So with Trends in AI, we're going to take a little bit of a summer break. Thanks for joining us here in Lab 42. Thanks for joining us online. We're going to be coming back after the summer, but not with a regular edition, but with the Transformers at Work symposium workshop. That's going to be here on September 15th in Startup Village on Science Park in Amsterdam. And we have the first announcements of speakers. So we're going to have Niels Reimers from Cohere, Suzanne Verberne from Leiden University, Douwe Kila from Contextual AI, Madelon Hulsebos here from University of Amsterdam working on table representation, and Rodrigo Nogueira, not to forget, from Zeta Alpha, Unicamp, and Neuromind in Brazil. Any idea what you're going to talk about, Rodrigo?
Pre-training transformers, maybe?
There's still time to put together the most fantastic talk like you did last year. So thanks for joining us online. And we wish you a great weekend and a great summer holiday. And see you back in September.